going to see, let's see here, the angles on the left are both two y's and y's. The angle on the right is just a y. So let's first replace that. A little different here because I got a squared. So what I'm going to do is write that as sine 2y times sine 2y. And then I'm going to worry about this other one here in just a second. Okay, because sine 2y is going to be replaced with one identity, and again right there. The identity for sine of 2y is 2 sine y cosine y times 2 sine y cosine y, and then plus 4 sine to the fourth y. Alright, let's keep on going. This is really all big one term. It's all multiplied together, so really it's 4 sine squared y cosine squared y plus 4 sine to the fourth y. Well, with what we're working towards on the right side is just a sine squared. Let me see about breaking this term up. Let's see if I can write it as, let's see, sine squared and sine squared maybe? Kind of like that maybe? Okay, so now between these two terms, what we have in common is the fact that we have 4 sine squared y in both of them. So if I factor that off, it leaves me with cosine squared y plus sine squared y. And what's cosine squared y plus sine squared y? All of that is 1. So the answer is just 4 sine squared y, and call it done. And honestly guys, it wasn't until about this step right here that I finally actually started seeing the answer. Before then I was just like, okay, keep my fingers crossed, hope this works, kind of pushing through it. So it really wasn't until about that step right there when I started seeing, maybe I can factor a little. Oh, and that leaves a 1 behind, so that's kind of, just keep pushing forward. Even when you're like, there's no way I can have this right, just keep going with it. You never know what's going to come up. Okay. All right, next one. We have a cosine 2x and a cosine 2x that we would like to replace, shrink them down just to single x's. So let's go with 7 plus, what do we replace these with? We have our 3 formulas. What do we want to do? Gosh, all I can think of is because everything on the right has just secant, and secant relates to cosine, that maybe I'll just use the identity where you have cosine of 2x is equal to 2 cosine squared x minus 1, so it's all in terms of just cosine. So let's try that. So far I've been really lucky, but maybe this one I'll mess up, and then you can see me erase it and we can try it again. Okay, we'll see. All right, let's clean up along the top. That would be 7 minus 1 is 6 plus 2 cosine squared x. Down here in the bottom, the 1's cancel away, so I just get 2 cosine squared x. And then minus 1 equals, oops, not doesn't equal 0, I'm used to saying equals 0, we're used to doing equations. Equals, we're going to hope to get to that right side. Okay, I have two things on the left. I have my fraction minus 1, and then eventually I'm trying to get one term. So obviously we want to combine these together. So let's write it like this, to where we can combine them together. So it'll be minus 2 cosine squared x over 2 cosine squared x. So just rewrite 1 so that way I can combine these two fractions together. So 6 plus 2 cosine squared x minus 2 cosine squared x. And then down here in the denominator, keep the common denominator of cosine squared x. In the top, it looks like 2 cosine squared x minus 2 cosine squared x goes away. So all I have is 6 over 2 cosine squared x. Well, 2 divides into 6 3 times. 3 over cosine squared x. Well, would y'all write that as 3 times 1 over cosine squared x? Isn't that the same thing? And it is. So 1 over cosine squared x is secant squared x. and we can check that off and call it done. So I guess let's go back to where I had that initial hunch of what to replace these with, is because that right side was only in terms of secant, which really is cosine, that I chose to use the formula over here of shrinking the angle of 2x just to the formula that just had cosine in it. Okay, coming to an end here. Let's work on this problem. Well, eventually we're going to actually have to increase our angle, because over here on the left we have nothing but y's, whereas the angle on the right actually has 2y in it. So I guess the first thing I can think of is we have two fractions on the left, we have one fraction on the right, so let's at least get common denominators so we can combine these together. And when you don't have a thing that looks really similar, you always just multiply them together to get that common denominator. Okay, the top on the left had just a 1 in it, and the bottom had the 1 minus sine y, so it just needs a 1 plus sine y. And the one on the right needs the 1 minus sine y. Okay, being very careful as I go across the top. 1 plus sine y, and I want to make sure I subtract everything that's coming off over on the right. So minus 1 and then plus sine y. And then down the bottom, we can write that. I don't know if you guys want to go ahead and FOIL them out. So the 1 minus sine y times a 1 plus sine y, they're conjugates. It'll just get 1 minus sine squared y. Okay. So in the top, the 1's go away. You get 2 sine y. In the bottom, we have 1 minus sine squared y. Okay? Well, look at the denominator that we're eventually wanting to go to. The denominator needs to have cosine in it. Do you see how 1 minus sine squared is cosine squared? So we have 2 sine y over now cosine squared y. And all I have to do, we're really close to our answer. The denominator has a cosine cubed. Our denominator right now has a cosine squared. So what if we multiply the top and the bottom by cosine y over cosine y? Okay, well, up in the top we'll have 2 sine y cosine y. In the bottom we'll have cosine cubed y. And if you look really closely at this right here, that's our formula for sine of 2y. And then we have cosine cubed y. And that problem's done. Okay, F. We're going to replace two of these, cosecant 2y and then cotangent 2y. I don't know cosecant, but I know it's 1 over sine of 2y. And I know cotangent is cosine of 2y over sine of 2y. Okay, right away, before I start replacing the two y's and shrinking them down, I just realized I've got two fractions here, already have a common denominator right now. So let's go and combine them together as 1 minus cosine of 2y. And in the denominator is sine of 2y. And then from there, now we'll shrink because we're eventually going to a tangent of y. Okay. Well, the bottom, I only have one formula, 2 sine y cosine y. And I'll do a 1 minus, and what do I want to do with the top? I've got three options here. What looks good? Let me take a shot in the dark with this one. I'm about to put a replacement in behind a minus sign, so I'm going to put it behind a parentheses. Let's go with the 1 minus 2 sine squared y. The only reason why I chose this one is the fact of right here. When I distribute the negative, I'm going to get 1 minus 1, and that'll take those two away. And that honestly is the only hunch I'm going off of, and I just hope it works for everything else. So finishing out, it'll be 1 minus 1 plus 2 sine squared y over 2 sine y cosine y. So 1 minus 1 goes away, and I have 2 sine squared y over 2 sine y cosine y. Well, the 2's go away, which is great. One of the sine y's down here cancels with 1 up there, and I just get sine y over cosine y, which is tangent y, and we can check that off. So that was actually a really good guess. If that didn't work out, y'all, come right back in there and just replace it with a different formula. That's all I would have done. Okay, last problem. With this one, we're going from a 4t all the way down to single t's. You can see them all here. Well, our formula only shrinks them by half. So we'll go from a 4t down to a 2t, and then we're going to go from a 2t down to half of that, which is single t's. So it's almost like we're going to pretty much have to be using our formula twice that we learned in this section. So sine of 4t would be 2 sine of half of that, which is 2t, and then cosine of 2t. And then again, let's shrink both of these again. So we have 2 times sine of 2t would be 2 sine t cosine t. And then, of course, as always, we have to think here. Well, because both of these terms over here on the right side have both sines and cosines, I'm thinking we might go with cosine squared t minus sine squared t. So let's cross our fingers. Let's hope I'm 3 for 3 in this one. And if not, again, come right back here. That's where I'm replacing to start another attempt at this. So 2 times this times this. So let's go ahead and blend this with that real quick and write it as 4 sine t cosine t. And then we're going to multiply it by cosine squared t minus sine squared t. And I love writing equal 0, but not quite. All right. Multiply this front term into both of those. We'll get 4 sine t times cosine cubed t minus 4 sine cubed t cosine t. And we arrived, which is a good guess.